Alright guys, so let's continue our discussion on the PLC and controllers. Now, I'm hoping you guys have installed the Logix Pro, which is free for 2 weeks, okay? And then after that, we will figure a way out to get that for 3 months, okay? Alright, so what we need to do is we need to open Logix Pro. So I'm going to come here. So you type in here Logix Pro, and this guy he comes in, and I forget to put a link for this software in the previous video where I mentioned the installation. So after I'm done with this video, I'm going to do that. So here it is loading, and in mine it just came out and I can start working on it. But in case it does not and you want to open another file, so what you do, you go to file, new, and then you just select this guy right here and say okay, and there it is. All right, sometimes it's hard to, if you click right here, then this thing become, you think, how do I make it small? See right here, so make it small this way. We want to see I/O simulator, so we can see input outputs. So we come right here to the simulator, I/O simulator right there, and there it is. Okay, again, let me take this out, and if you see this guy, just take him out and you will see this window. So sometimes the students have issues not seeing this, so I'm saying just cross this out. There we go, cross this out, and then you will see this. Okay, so in this one, we're going to look at a small example again, and we're going to look at a seal-in circuit. Seal-in circuit. So let me show you what do I mean by it, and then we will do it on the PLC. Okay, so I'm it the one note, and that is probably the probably you would see it a lot in the industry, especially for the beginners. It is important because in a lot of tests, these kind of circuits you would see. So I'm gonna come quickly right here, and it is easy. We're gonna say view right here, draw. So seal-in circuit. Okay, what is mean by seal-in circuit? Here we go, and this guy, and then you got this guy. So let's say this is a coil, and I'm gonna just put this guy, which is normally closed, and this is normally open push button, normally open push button, and this guy is an auxiliary contact. We will talk about that. An auxiliary contact on a contactor. I will talk about contactor later on. This is what start and stop the motor. Start and stop. See, this is a beginner level course in electrical engineering and in information technology. So the students learn about PLC and several types of controllers, and that is so we are talking very basic programming here. All right, so we got a normally closed instruction here, and then we got a normally open push button, and we got an auxiliary contact, and we got a coil. Okay, what I'm saying here is this, that if I press this button right here, if I press this button, this push button, what happens is I got a path. I got this path right here. This path get established, and then this push button is released. The push button is released, but the circuit is going to be live. Okay, these instructions, all this path is going to be true. I hope you guys are getting it. So all I need to do is push this button once, and then after that, what I have this path right here, which stays true. Okay, So how do I de-energize this coil? To de-energize this coil, we open this normally close instruction. All right. So this will get de-energized. Let me show it to you. Maybe the theory doesn't make sense. And believe me, you guys will understand this better as we go on. So just stick. All right. So let me show you on the PLC. Let's design this quickly. So I'm going to come right here. Logix Pro. And it's very easy as you practice more and more. Okay, I want to make this guy right here. Right here. This is going to be our normally open push button, and this is going to be an auxiliary switch, and then we got an output. All right, and what we're going to do is we're going to say, hey, you are who this guy is. He is this guy, but who is this normally open switch? He is I:1/0. Input card 1, connection 0. He is connected to the PLC card, and card 1, and card 1 he is connected to connection 0. Okay, so I:1/0. I just called him a let's call him normally closed. Let's make it normally closed push button. Okay, so let me change this. You right click on it. Sorry, normally open push button. Okay, normally open push button. And see, he is 0, this is 1, so this will always stay true. Okay, then we got, this is the normally open I:1/1. It's going to be a normally open push button. I'm gonna say normally open push button, PB. Okay, and this is that seal in. This is what seal in our circuit. So I'm gonna call it seal in. Okay, and this is going to be I:1/2. Okay, sorry, no, it's not going to be I:1/2. Watch here. Okay, watch here what I'm going to do here. So the output, we're going to say O:2/0, and you guys know what it means. O:2/0. Okay, O:2/0 means output car 2, and car 2, this whatever this is, that is, let's say it is a motor. Okay, let's call it motor seal in, so you guys are not confused. Motor seal in. Okay, motor seal in, and we are going to watch this. I'm going to use that output as an input. O:2/0. There we go, and that's how it gets sealed in. When this guy is, okay, so this is how it works. Let me show you. We go. So what we do is, this guy is true because this is 0, this is 1. Is this guy true? No, he is not true. But if I say this is a normally open push button, yeah? So if this normally open push button is pressed, he's going to be 1, and this is 0, so 1 and 0, so this will become live. When this is activated, this output, what is going to happen? This guy is going to get activated, and wow, we can release this push button, but this circuit is going to stay live. I hope you guys are understanding. So for the online folks, if you don't understand, leave a comment down, and for my class, my students, you guys can text me, or you guys will see me next week, so you can ask questions or send me an email. Okay, let me download it so you guys can see. Download and go online, and let's run it. So if I push this button right here, look at that, this motor is running, and it's going to keep running. How do we stop this motor from not running? We click on this guy. Look at that. This is a basic, very basic seal in circuit. I have not used overloads or things like that. If you understand this very, very simple circuit, you will do very good with PLCs. Let me repeat. So this is 0, this is 1, okay? So electric is flowing, let's say the signal is flowing for analogy, for the sake of understanding. So let's say this up to here, it is true, okay? But this is not pressed, so let's press this. When we press that, because this is normally open push button, so you press it and then release. After that, what happened? This output is on, but I'm using the output as an input. So if this is on, this input is going to be on. So we have established this path right here, and that path is keeping this motor sealant energized. Okay, or let's say motor is running for now, because we haven't talked about a contactor and relays and stuff. So and then if there is something going, I want to stop this, I want to stop the motor, so I click on the push, see on this push button, what happens? I make it 1, and it is 1 right here. So 1 and 1 will stop the signal going through. I'll stop just for understanding sake. Let's say electric is not going to flow this way. Okay, just for sake of understanding. Because what really is going on is the CPU is checking the status of these instructions, and based on the status of these instructions, it is making logical decisions, like it is ending and not gate, and which we will talk about, and then OR gates and NOR gates and stuff like that. I hope you guys understand this. If not, please ask me questions. All right.